Their small workshop uses brass for casting to ensure that gear reducers in Pakistan can use durable worm gear drives. Even though they employ a copper-clad iron technique, the finished products are extremely sturdy and durable. The thickened block of ductile iron in front of us is the raw material for making the iron core of the worm gear. Since the dimensions of the iron block don't meet usage requirements, the craftsman first measures it with a steel ruler and then uses a lathe tool for cutting. Not only must the cut surface be smooth, but the rust layer on the surface must also be removed entirely. To fix the rotating shaft, the iron block center needs to be drilled with a twist drill, and different drill bit sizes are used to enlarge the hole. Although the hole diameter isn't precise at this stage, it allows for subsequent heating. While the lathe chuck holds the position, the craftsman must also cut the other side of the iron block to ensure both surfaces are identical. After making the surface shiny, the outer edge of the iron block is machined to create steps, ensuring better adhesion of the molten copper and more contact points with the core to prevent the copper outer ring from falling off during use, thereby enhancing overall integrity. The same cutting amount is applied to replicate the rounded projection on the other side. With careful caliper measurements, the rough machining of the iron block is complete. The iron core's exterior is drilled with holes to further improve the fit of the copper outer ring. This ensures that the formed copper ring will securely lock into place during molding, providing a certain degree of limit. At this point, the iron core meets the casting requirements. Since the worm gear needs to be molded, the craftsman mixes waste motor oil with sand to increase the sand's viscosity, preventing mold cracking or breaking. The sticky sand is then packed into their sandboxes, each layer compacted with an iron rod to prevent hollow areas that might cause the sand to collapse. Next, the level aligns the inner mold, and the sand is leveled within the sandbox. After removing the inner mold, the contact surface is entirely flat. A layer of talcum powder is sprinkled on top to facilitate later demolding. After the simple creation of the mold, a large amount of molten copper is needed for casting. They use recycled copper, mixing brass, and red copper, which does not affect the final product's quality. Once the furnace is filled with copper, it is melted at high temperatures. Using heavy oil for combustion, the furnace temperature rises rapidly. To prevent the iron core from being insufficiently heated during casting, the iron core is preheated simultaneously to ensure good casting results. After 10 minutes of heating, the annealed iron core meets the required standards. The surface stains are cleaned with a wire brush to ensure the molten copper adheres firmly to the surface. After verifying everything, the iron core is fixed in the center of the mold. By now, the copper has melted into molten copper. To prevent it from cooling and solidifying, the craftsman quickly pours it into the mold, filling the gaps between the iron core and the inner wall. Once all the molten copper is poured in, it levels with the iron core surface. To better integrate the copper and iron core, the casting is allowed to cool for 12 hours to prevent outer cracks. Then, the hardened sand is loosened and removed using a hammer, revealing the formed worm gear blank. However, the surface still doesn't meet basic standards, so the craftsman processes it using a lathe, removing excess material and improving smoothness. Though this thins the worm gear, it's within the normal processing range, achieving the precision required for the crankshaft. With the craftsman's expert handling, the rough machining of the blank progresses quickly. Despite not having high-end lathes, the overall machining precision is very high. In their skilled hands, the initial hole diameter not meeting connection standards is adjusted by comparing it with the gear reducer's shaft diameter and enlarging with an internal dull tool until a perfect fit is achieved. Once the worm gear surface passes inspection, teeth are machined on its side using a high-end gear hobbing machine to interact with the worm shaft. Following the teeth cutting, the side is grooved according to the worm shaft's pitch using the gear hobbing machine. Copper-clad iron is used for the worm gear to improve precision, ensure smooth operation of the gear reducer, and reduce noise during use, greatly extending the lifespan of both the worm gear and the steel worm shaft. After half an hour of gear hobbing, the worm gear teeth are formed. Thus, the production of the copper-clad iron core worm gear for the gear reducer is complete. So, how would you rate the Pakistani craftsman's method of making worm gear drives?